When the wax is heated, it becomes very malleable, and through a process of heating, stretching and folding, a thin strap of approximately 1 millimeter thickness is created to wrap around the core. The fineness of this strap means that the resulting metal sculpture is thin and light.
Hindu, Muslim, Sikh, Isai, sabko mera salam. Chaliya mera naam.
The core is heated to encourage the wax to adhere to its surface. The whole surface of the core is wrapped with this ribbed strap, which produces a corrugated effect typical of the Dokra sculpture. Unlike beeswax or petroleum-based waxes, the resin-based wax becomes brittle and hard very quickly. This helps the model retain its surface design, which can become spoiled with too much handling. In the Western practice of lost wax casting, metal pins are used to hold the core to the outer investment layer. This is something the Dokra metal casters have knowledge of, yet don't apply due to their conservative nature and adherence to tradition. This is despite the technique having a less than 50% success rate, which might be partially due to the core moving inside the investment. Another reason could be the lack of vents, as mentioned earlier, which allow for the escape of gases, although the fineness of the wax strap used to wrap the core means that the amount of wax used is kept to a minimum. Also, the clay doesn't have the consistent refractory tolerance to heat of more sophisticated material. Occasionally, other waxes are used. For instance, the warrior figure shown here has his headdress and skirt made from beeswax. The figure is rinsed with water to clean its surface and to cool and harden the wax. The first layer of investment is applied to the wax surface. This is made from 1 part clay to 1 part cow dung. The properties of this mixture absorb the liquefied wax in the melt-out stage. The mixture also has a very plastic quality, which is important in capturing the surface detail. This is left out to dry, and then another layer is added, with the same sand-clay proportion as the core. The fact that the crucible is attached to the mold is one of the most striking differences between the Dokhra technique and other casting techniques. The crucible is made from the same material which is used to build the core and the outer investment layer of the figure. The shape begins as a cylinder, with a hole poked through the center. Gradually, one end is recessed and worked into a cup shape. The other end will be connected to the invested figure. The point of entry of the brass is decided, and at this point is placed a thin wax rod called a sprue. At a later stage, this, along with the wax figure, will be melted out to leave a channel into which the molten metal will travel. The metal will then fill the space which the wax figure previously occupied. The point of entry is chosen with the flow of molten metal in mind. It is important to place this entry point in a position where the metal will flow to all parts of the empty space in the mold. The placement of the entry point for the molten metal should take into account the following factors. It needs to be accessible for its eventual removal, sympathetic to feeding the molten metal into the empty form, and not disruptive to the surface detail of the sculpture. The crucible is then filled up with small fragments of brass. The smallness of the pieces of brass aid in the speed of melting. A flux is sprinkled on top of the brass to reduce the amount of trace metals being lost in the melting. This is then sealed with a cap of investment. Through working with this technique closely for years, the workers show great skill in estimating how much brass to put in the crucible. This eye estimation can also be seen operating in the measurement of coke used in the firing stage. It is through a profound familiarity with the various steps of the casting process that the workers can actually decide the various measurements. Into the side of the crucible, a hole is cut, approximately 3 inches in diameter. This will allow for the gases to escape from the mold and will also provide a way of monitoring the melting of the brass.